All right, so now we're going to talk briefly about loading our own data. If a simple heart risk data set is too simple, right, because we have a couple of fields and they're too predictive, it might be good to talk about how we could load our own image and audio data so that we can do more interesting things. And I'm making wiggle quotes, right? Now, I have some trepidation as I say that because I really don't want y'all to think that, oh, we have to do an image project or, oh, we have to do an audio project. You don't, right? This is just useful for those of you who might want to, right? Who might decide that an image data or audio data project is useful if you are equipped to do it. Okay? So to load data, we can use the Python libraries Pillow and pysoundfile. Pillow is pretty good at processing images. It is a replacement for PIL. PIL is, I believe it is, Python Imaging Library. Excuse me. It is an older Python library that was kind of popular in its somewhat niche purpose. It was abandoned by its creator, as sometimes happens with open source projects, right? The developer loses interest, decides to move on, whatever, and an open source project becomes an orphan. Pillow is a fork of PIL that continues development and fixes some old bugs, right? And the name is a clever pun because why did draw mode not engage? Stop it. No. Wrong. There we go. The name is a clever pun because PIL, right, is the first half of Pillow. So pysoundfile is good for processing audio. Pysoundfile, I believe, can open any raw format, right? Or many, I should say, raw formats. Notably, I'm pretty sure it can open WAV and FLAC, okay? Unfortunately, it can't open MP3 or OGG or AAC, but it is fairly easy to just convert one of those into a .wav or .flac, right? So on Linux, if nothing else, FFmpeg will do that pretty easily. And VLC has a graphical front end. You have to find it, but there is a transcode option in VLC that will also do that for you, right? But assuming you are armed with a bunch of .flac or .wav files, then pysoundfile will give you an easy way to just open one and get a NumPy array of all the samples in it. And notably, it already converts it to floats in the range 0 to 1, right? So it already does that for you. Pysoundfile depends on the C SND file library. If you are on Linux, you have to install this from the package manager for your distro. That's not hard. If you are on Windows or OS X, libsnd file is included in the wheel. It's included in the redistributable image you get from pip, right? If you're using Conda, then you can install Pillow this way. It's real easy. Pysoundfile does not have an official build, so you have to get a community build from Conda Forge. Fortunately, that's not hard to do. You just add this. Right? And I'm pretty sure, not absolutely sure, but I'm pretty confident this is going to include SND file. So you don't have to worry about it, right? So here's your Pillow command. Here is your pysoundfile command. And you can also just pip install either of these if you want to. So here is... So these slides are going to be minimal because the main focus of this is going to be some big example programs. Here is a little snippet that will allow you to get a NumPy array that just contains all of your pixel data, right? So if you have, let's say a 500 by 600 image, right? This will just give you a 500 by 600 by 3 NumPy array. I believe that you're still going to have to normalize that the way we were doing before. You're still going to have to convert it to float 32, and then you're still going to have to normalize it into the range 0 to 1. Okay? It's going to return the array to you in the format that it is as image data. Potentially, this number might have to be different if the sample depth is different. I don't know what it does if you get a 2-byte sample format. You might then have to normalize over a wider range. But if you're using a PNG or a JPEG and it's just a normal, like 1 bit per channel or 1 byte per channel image, then you can normalize it the way we were doing it before, right? Convert to float, multiply by 1 over 255. Spray a cat with a spray bottle because she thinks it's dinner time, but it's not. 2 meals a day, Gracie, not 5. Okay. Oh, right. So I have called img.load, but you don't have to use it, which is why it's commented out. PIL will automatically call img.load the first time you try to use image data. So I tested this, and it works precisely the same whether you call img.load or not, because when you do this and reference the image data, it will automatically load it on demand. Very nice, right? Notice also that getting a NumPy array out of our... So I should say, right, what we're actually doing is two-step, right? We're opening our file as an image object, and then we're passing it into an np.array constructor, and that actually gives us our NumPy array, right? But that's very easy to do, right? This is not a complicated or involved process, right? Which is why Python and NumPy and PIL are all great. And PIL does a whole bunch of other stuff. It can save, it can resize, it can scale. We'll talk about some of that in the demo program. So that should say Pi Audio. Good job, me. I'll correct that. So... right? Oh gosh, and that should say sound. Holy heck. Good job, man. Proofreading. Alright, so this will get us a NumPy array with our audio data. This is incredibly easy, right? So notice the name is a little different. The package name is pysoundfile, but the import name is soundfile. Having a different package and import name is an unfortunate affliction that appears to be becoming common. But this is me importing a Chemical Brothers song, so I didn't have anything else in WAV format to hand. You can just do sf for soundfile.read file name, and that just gives you a NumPy array of your samples and a number that is your sample rate. Now, it is important to note, this is going to be of shape some huge number 2. For stereo files, like this WAV file, or huge number 1 for a mono file. Actually, I think for a mono file it doesn't even include the second dimension. So you have to check here. It's a little bit tricky, all right? If your file is mono, you just get a 1D huge array. If your file is stereo, you get an array of shape huge, comma 2, right? And it's extra tricky because the number of dimensions are different. Okay? So now, let us look at some sample programs.